scrolling. There it goes. Okay. Hi, Ellie. All right. I'm officially recording your meeting. So, okay. So yeah, thanks for joining me today. We are going to go through the Chapter 7 FRAPPY. Chapter 7 FRAPPY. I am going to share my screen so that you can see the question and then also the rubric. So heads up on that. That'll be coming in just a second. Now is a good time to find your FRAPPY if you've already completed it. If you haven't completed it, maybe you want to at least pull up the question either in your textbook, or I think the PDF is loaded in Schoology. I don't remember, but it is in your textbook, so you can look there and you can at least kind of follow along with us. So let's go ahead and do that. Oh yeah, I knew I was forgetting something. I need to get in the meeting in my iPad. I'm not sharing from my computer. I'm sharing from my iPad. Sorry. It's been a while since I've done this. You guys are the only ones I share a screen for. Turn the volume all the way down. Let's mute that, mute that, mute that, turn that off, and join. Okay. Now let's try again. So now I want to share over here. Here we go. Start broadcast. I didn't kill your ears with that, did I? I think my volume is all the way off. Okay, good. All right, there we are. Meet broadcast. Okay, now let's go back here. So Chapter 7 FRAPPY. So in Chapter 7, we get into sampling distributions. And we looked at sampling proportions, and then we also looked at sampling means. And your Chapter 7 FRAPPY was on sampling means, and it was also on a distribution that was skewed, not a normal distribution. So we had to think about how we deal with that and what we do with that. So here's the question. The question was, the principal of a large high school is concerned about the number of absences for students at his school. To investigate, he prints a list showing the number of absences during the last month for each of his 2,500 students. For this population of students, the distribution of absences last month is skewed to the right, with a mean of 1.1 and a standard deviation of 1.4. Suppose that a random sample of 50 students is selected from the list printed by the principal, and the sample mean number of absences is calculated. So we have a parent population of 2,500. The population is skewed to the right, as you would suspect. That makes sense in my head when you think about absences, because a whole lot of people are not going to have very many absences at all. But then there's probably a few people that might have a whole lot of absences, which is what makes it skew up to the right. So we know it's a skewed distribution. Now we're going to look at taking samples of 50 students. Okay. So part A was, what is the shape of the sampling distribution of the sample mean? Okay. B was the mean and the standard deviation. C was, what is the probability? So then you find some probability. And then D, you kind of had to extend your thinking a little bit and think about what it would look like to use to find the sampling distribution of the median instead. Okay. So here's our model solutions. So remember, this is the model solution. I'm going to go through what the model solutions should look like, and then I'm going to talk about how each one was scored. So the model solution for part A, it says the sampling distribution of the sample mean will be approximately normal because the sample size is large. And then in parentheses, they show 50 is greater than or equal to 30. Does anybody remember, how do we get to go from a parent population that's skewed right to a sampling distribution shape that is normal? How does that happen? What do we have in place? Which I'm shocked that this is not part of the model solution. But what do we have in place that allows us to do that? Does anybody remember the name of it? No? You may remember and just not want to talk, and that's okay. It's because of the central limit theorem. When we got into 7.3, the last lesson, the last piece of that was on the central limit theorem. And the central limit theorem tells us that if we take sample means of a sampling distribution, we pull a sample size and we take the mean. As we take the mean of those samples, we approach a normal distribution. And if our sample size is large enough, we can call that distribution approximately normal. So I'm kind of surprised here that in their model solution, they don't reference the central limit theorem. In my solution, I said something along these lines: the sampling distribution of sample means will be approximately normal because the sample limit or the sample size is large. And then I said, according to the central limit theorem. So I named it. I think the fact that you say that the sample size is large is probably enough. I like how they put the sample size in parentheses there. They said 50 is greater than or equal to 30, which 30 is kind of the standard number of what defines a large sample. So 30 is typically what we use. Okay. All right. So that was part A. You had to get at the fact that the sampling distribution of the sample means was normal. Once you establish that your distribution shape is normal, then you can go on and find the mean and standard deviation, which is great. So in part B, you were supposed to find the mean and the standard deviation of the sample size. Well, really helpful for us, the mean of the sampling distribution is going to be equal to the mean of the parent population, which in this case was 1.1. So that's this piece right here. And I don't know if you can see, but that the mu has an X bar by it. That tells you that it's the mean of the sample means. So you have a whole bunch of samples that you're taking the mean of, and then you take the mean of all of those samples. So it's tricky because it's like you're doing means a whole bunch of times for individual samples, and then you're taking the mean of that whole distribution. But the point is that mean is going to equal the parent population mean, which is 1.1. You also need to state that the sample size is less than 10% of all students. And you actually have a number here. You know the size of the parent population because you're told that there were 2,500 students in the school. So you can say that 50 is less than 10% of 2,500. That's an important thing. Because that is true, because of this, you can now do that. Because you know that the sample size is less than 10% of the whole population, then you can calculate the standard deviation safely. We don't have to worry about that fact of not replacing our subjects. That's why this is important. Because once you sample someone, you don't put them back into the pool to then be able to pull them again. So that's why you need to know that your sample size is less than 10% of your parent population. So then you calculate the standard deviation. And again, you'll notice that they have the sigma with, I'll try to write it larger here. They have the sigma with the X bar underneath. That just tells you that it's the standard deviation of the sample means. Okay. This equation right here, this guy right here, will be given to you in your formula sheet on the AP exam. You get a formula sheet. So that equation right there will be given to you on your formula sheet of the AP exam. That's good to know. You don't need to have it memorized. You need to know where to use it. That's not told to you, but you don't need to have the equation itself memorized. So because we established the 10% condition, we can now use this equation. We take the parent standard deviation of 1.4 and divide it by the square root of n, which is 50. And here's your standard deviation. Okay. So these are like the three pieces that are important in that section. State that the mean is equal to the parent mean, the population mean, which is 1.1, and state what it actually is. State the 10% condition, and then state the standard deviation using that equation. Okay. So we've done a couple things. We've established that the population is normal. Then because the population was normal, we're able to use the mean and standard deviations that we know. And then because we can use the mean and standard deviation, now we can find probability. Because now we know all of the things that we need in order to find probability given a normal curve, you know, given your normal curve. So it says X bar, meaning the sampling distribution of sample means, has roughly a normal shape with mean 1.1 and standard deviation 0.198. That's what that set of parentheses is. The capital N means normal. Then inside parentheses, you do mean, comma, standard deviation. So mean of 1.1, standard deviation 0.198. We want this probability that the mean is less than 1. So they always show the z-score calculation. I think most of you probably go towards the technology piece using your normal CDF and your calculator, and that's fine. You're allowed to, as long as you label these. Are you sick of me saying that yet? I tell you that every single time I write it down. Don't forget to label your lower bound, upper bound, mean, standard deviation. You can't just write the values in. You have to label what the values mean. Okay. So you can do the z-score if you want. If you remember how to use the z-score, sorry, all my messages are coming through here. If you remember how to use the z-score, great, go for it. Or use your technology. Once you have established this, now they wrote it out. You may have drawn a curve. I default to drawing a curve. I think showing the picture is really beneficial. So that's what I do. They didn't draw the curve here, and that's okay. They stated that the population was normal. They stated what they were trying to find. If you show those two pieces, then you're okay. I draw the curve because I think I just do better with it. I like seeing the visual. And then you can list out this using technology. Here's your normal CDF, lower bound, upper bound, mean, standard deviation. And then actually answer the question. Put what the probability is. Okay, that was part C. Now in part D, they asked you about doing this with sample medians, which was funny because we have not talked about sample medians at all. But you can. You can do a sample median instead of a sample mean. You know, we can calculate anything we want. There are times where it makes more sense to calculate your grades using a median instead of a mean. Because if you think about it, the mean follows the skew. Go back to chapter 2. Mean follows the skew, right? So if you have a whole bunch of B's and you get one D or one F, your mean's going to drop because of that one F. But if you use the median is a more rigid measurement. Your median is going to stay pretty consistent. So there are people out there, Mr. Berg being one of them, who argue that we should be using different calculations for grades because mean is not always the best calculation. Okay, anyways, my point being, you can find a sampling distribution of sample medians. All they want you to get at here is take many, many random samples of size 50, and then for each sample, calculate the sample median, and then calculate the standard deviation of the distribution of the sample medians. That's it. You need to just clearly say that you're going to do this many, many times. You're going to use a sample size of 50. Because you're using a sample size of 50, that's what allows you to use the standard deviation. Since your parent population is skewed, you need to use a large enough standard deviation so that your distribution falls normal. If your distribution falls normal, then it doesn't make sense to, sorry, I said that wrong. If your distribution doesn't fall normal, then it doesn't make sense to use standard deviation. That's why this piece is important. Okay. Model solution, that was that. Before we start scoring, does anybody have questions about the model solution?
Would you mind, you said you would rather draw out the graph than write it out. Could you just show us really quick what the graph would look like?
Yep. So I'm just going to do it on this little pink one that I have over here. So it'll be kind of small. But you'd have your 1.1 in the middle because of your mean. And then your standard deviation is the 0.198. So this would be, what is that? Add 0.2. So 1.298. And then subtract the 0.2. So 0. What is that? I don't have my calculator out. But yes. So I would mark at least one increment in either direction. Minus 0.198, 0.902. And then the other thing, so that's important. You draw your normal curve, you mark your mean, do at least one increment in either direction. Then you also have to mark the part that you want to find. So then I would also, I keep picking a lot of colors that look similar, sorry. So then I would also mark what I'm looking for. I am looking for x is less than 1. So mark your 1, and your graph doesn't have to be to scale. This isn't like an architecture drawing where it needs to be to scale. As long as you label it, this is not a drawing test. This is not a grammar test, and this is not a drawing test. This is not a spelling test. So it doesn't necessarily have to be to scale. So just, it's okay, as long as you label it. So I'm going to say that this is where I have a mean of 1. And I'm looking for less than 1, which means I'm going to shade underneath. Okay. So that is the proportion that you're looking for. What is that probability? That's what my graph would look like. Does that help?
Yes, thank you.
Yep. Okay. All right. So I'm going to scroll here and let's start scoring. Oh, I went too far. I don't know how to use Notability. Okay. There's part A. So here's where your EPI, essentially correct, partially correct, or incorrect. Those are your 3 options. So in part A, you are essentially correct if the response includes the following 2 components. You state that the distribution shape will be approximately normal. Notice the word approximately is in italics there. It's very rare that we're going to call something normal. We are almost always calling it approximately normal. Okay, especially when you go to from a parent population to this is a distribution. This is a sampling distribution. This is not the whole population. So it's hard to call a sampling distribution normal when it's their samples. They're samples. So they're all different and whatever. It's never a perfect normal distribution. Okay, anyways, so approximately normal is important. Then the second component is includes a justification that compares the sample size to a reasonable boundary value. So they did it that way. Okay. So that is a big part. You may state the central limit theorem, but you need to state why this example fulfills the central limit theorem. Okay, it fulfills the central limit theorem because 50 is greater than 30. Okay, partially correct if you only have one of the two components, incorrect if you don't have either. Okay, I can promise you that this word will be important. So just a note for that. You never want to call it normal. It's approximately normal. So remember, statistics is the land of gray. Almost nothing, see, even me being gray right now, almost nothing is black or white. It's all in the middle. It's all gray in the middle. Okay. It says, note responses that state that the distribution is normal, there it is, are not sufficient for the first component. See, I didn't even continue reading and I already knew what they were going to say. You can't say that it is normal. You have to say that it is approximately normal. The second one, responses that do not include a specific boundary value, 30 or 40, are not sufficient for the second component. Examples are insufficient, examples of insufficient justifications include because the sample size is large or because of the central limit theorem. So you can state the central limit theorem, but you still need to state the sample size. Okay. Good deal. Moving on. All right. Part B. Part B is essentially correct if you state the correct value of the mean and you calculate the standard deviation correctly and shows work. Lots of you missed that in chapter 6. I'm going to tell you right now, you will not pass your AP exam if you do not show your work. I promise. You have to show your work. And a lot of you did not do that on some of your free response questions in chapter 6. So please make sure, and you less credit for it. Wah, wah. So be careful there. Show your work. Okay. Partially correct if the response correctly includes one of the two components. So if you only did one of them. The good news here is the mean is really easy. Means easy to the parent population. So it's real easy to get a P on this one. Okay. And then incorrect if the response does not satisfy the criteria for E and P. And by the way, calculates the standard deviation correctly includes stating that 10% condition. You will not get full credit if you don't state the 10% condition. I can promise you that. That's part of the calculates the standard deviation. That's just part of that process. Okay. Questions on B? Okay. Part C, essentially correct if the response includes the following three components. Indicates the use of a normal distribution. Clearly identifies the correct mean and the standard deviation. Or uses normal distribution with mean and standard deviation found in part B. Basically, you're stating that it's normal. This is the one where you had to find the probability. when you, I'm going to go back up to the model solution. Hold on one second. We talked about, yes, this was where we were talking about the curve. You either show the curve or you state this stuff with the notation. Those are your choices. Okay. So somehow state that it's normal. That's what they mean by that. Either show the curve or use the notation. Then the second one says uses the correct boundary value. That's where you're showing that you want a mean of less than 1. So that's that piece on my curve where I drew in the line and shaded to the left. Okay. They stated theirs. In the model solution, they said, we are looking for a probability of X being less than 1. X bar, I should say. Okay, so using the correct boundary value, that's a really easy thing. But when you're drawing the curve, even when you're writing it out, it's often a thing that is forgotten to be mentioned. I said that funny. People forget to mention it. Okay, people forget to write that out. That is a thing that they want to see. They want to see that you draw in the region that you want on the curve. Okay, and then reports the correct normal probability consistent with components 1 and 2. So that's where you're either doing the z-score or you're using normal CDF, labeling your values. Okay. Partially correct if the response includes 2 of the 3 components listed above. Incorrect if it does not satisfy E or P. So if you only did the part 1 and not the rest, it's wrong. You're going to get an I. Okay. So here, let's look at our notes. It says, note, the following are examples of clearly identifying parameters for component 1. So here are all the ways that you can show that this distribution is normal. You can write mu and standard deviation. Write out the mu and standard deviation. That is enough to tell them that you're using normal distribution. That makes me nervous. I feel like they need to see more than that, but they say it's enough. Another way, showing the z-score. Z-scores are only done with normal populations or normal distributions. So if you show your z-score calculation, that means that you're assuming the distribution is normal. Okay. Explicitly labels the mean and standard deviation in a normal CDF calculator statement. Look at that, explicitly labels. Explicitly labels in normal CDF. You can't just write the values. You have to label them. Sketches the normal curve. Labels 1.1. Labels 2 additional consecutive values. I've never heard of them docking you if you didn't do 2. If you show 1, so I feel like 2 consecutive values means like 1 in either direction. I think that's what they mean there. I don't think it needs to be 2 in either direction. I think 1 in either direction is sufficient. I've never heard of somebody being docked for that. So 1 in either direction is sufficient. I think that's what they mean by 2 additional consecutive values. Because, you know, you've got the mean in the middle. So 2 consecutive would be 1 in one direction and 1 in the other direction. Okay. Here's another note. A correct z-score calculation is sufficient for components 1 and 2. That's why some people like doing the z-score. Because when they do the z-score, these are like the lazy mathematicians. The lazy mathematicians like doing the z-score because they don't have to draw a curve. They don't have to write anything. They don't have to like use punctuation and capitalization. They just do z equals whatever it is. Then from there, p equals whatever it is. It eliminates a lot of that because you only use z-scores when you're looking at normal distributions. So listing the z-score is sufficient enough for stating that you know the distribution is normal. And then the z-score also gives you the calculation to find the probability. That's the lazy man's way out. Take it or leave it. Then the last one, incorrect use of statistical symbols lower the score from an E to a P, but not a P to an I. So if you had an E, but you used the wrong symbol, they're going to give you a P. So they gave an example here. Just an example of that. This would be going from an E to a P? Because you're missing this part, X bar. You're not showing where the mean is less than 1. You're showing where the mean of the sample means is less than 1. Tricky difference. That was one of the AP exam tips in our lesson video. When I talked about, there was a slide about an AP exam tip where you have to be careful about your symbols. Cool? Okay, moving on. Part D. So part D, it seems tricky because they start talking about medians and you're like, wait, what? Where did medians come from? They just want to see that you recognize, oh yeah, I can do this with a sampling distribution as long as my sample size is large enough. Then I'm going to fall into normal calculations and I can find the standard deviation. So, and you don't even have to carry it out. You're just explaining how you would do this. So it says, essentially correct if the response includes the following 3 steps. Take many samples of size 50. Calculate the sample median for each of the samples. Calculate the standard deviation for each set of the sample medians, or for the set of the sample medians. That's it. They just want you to recognize that it can be done as long as you're taking many, many, many samples of size 50, which allows you to use normal calculations. It says partially correct if the response correctly includes 2 of the 3 components, incorrect if it does not satisfy those. Okay. Here's the overall question score. Each essentially correct part counts as 1 point. There were 4 parts again, A, B, C, D. So 1, 2, 3, 4 points possible. Each P is half a point. If you're at a half, if you're at 1.5 or 2.5, it says use a holistic approach. So was that a gimme P? Or was it like oh, you're real close to an E, but this tiny thing made you get a P? Then you could probably bump it up. To decide whether to go up and down, they don't leave it in the half. And then depending on the overall strength of the response, blah, blah, blah. Oh, it says depending on see, this is a kicker sometimes. Depending on the overall strength of the response and communication, particularly in part D. Sometimes there will be free response questions where they're not going to, if you're in the middle, if you're at a halfway mark, they're not going to bump you up to an E unless you got an E on a particular part. Usually it's the last part. Usually the last part of the question is the one that makes you think a little different, go in a little different direction. You know, the first 3 parts here were very well linked. State that it's normal, find the mean and standard deviation, find a certain probability. Those 3 things very much go together. We've been doing those 3 as components, as a set, since chapter 2. It was part D that made you stretch your thinking. So there's a lot of times on the AP exam that they will not give you a 4 for a certain question if you didn't get a certain part correct. And usually it's the last part. Usually it's part D, or however many parts there are, whatever the last one is. Whew. Did we make it? How are we doing? Does anyone have any questions? I think the last page is blank. Yes, it is. Does anyone have any questions? All right. Okay, I'm going to stop our recording for now so that I can load this, if I remember how to do that. There it is.